And it's fair that those who don't make the bar to the top levels, even if they get to any level, it's solid. It's something they've learned, they've turned into knowledge, they can use it at those levels, at those optimum levels. Whatever they know, they really know, and they can use, even if it's grade 4 math. But it won't be like, I've done grade 8 and 9 math, and I don't know how to use anything. Actually, to be quite honest, I didn't understand anything. I don't know what the heck those formulas were all about. Some people you'll meet people who say that, I did math for 12 years. I hardly use anything I learned. Well, that's the difference. No, it's not what you use to do things with. It's how it trains you to think in a certain way. And it's that analytical, synthetic thinking mind which takes you everywhere you go, whether you're teaching history or you're working in a dig somewhere far away looking at the remains of old fossils, or whether you're going under the sea, or whether you're practicing psychology as a therapist. And wherever it may be, you take a trained mind that can look at what is inclusive, what's exclusive, what's separate, where it can delineate between where one idea begins and another idea ends. And, all those subtle things make a lot of difference in the benefits that mathematical thinking creates. They go beyond the products that we create. They go into a way of thinking behind the obvious. There's a whole lot that we do not know. And mathematics is remarkable in the sense that it helps you to move from the known to the unknown. It's a great journey. So curriculums, yes. Charismath will feed into any curriculum because it is the heart of any curriculum.
Also, what you were just saying is also applies the same with the Cambridge system.
Yes, sure. The Cambridge system, the Oxford, or any other system, or any other program, they all have very good intentions, especially today, to teach mathematics in a way where people understand the concepts, the things that underlie, that undergird mathematical operations. On top are numbers, but beneath them they're driven by ideas, mathematical ideas, connections between the obvious and not so obvious, connections between what is known, what we know, and what we do not know. They are connected. And mathematics helps explore that territory. And it's a fascinating journey. Now, all these systems try to get this to happen. They all want this kind of connections to be made in the child's growing minds so that they become powerful implements, tools for problem solving. And you can't go into problem solving if you don't have these tools as implements, which helps you to put things together, make those connections, and the moment you make them, out comes something which connects something else, and though you're leapfrogging towards a solution. And that's what these programs, everybody's trying to do that today, but there's not enough courseware. We don't have the kind of courseware that helps people to do that. We have lots of new pedagogical tools have come up, but the courseware, the content, organizing the content in such a way that anyone can read it and understand it. So unless you get to the point, just like reading a story, you have to get to the point where you can at least read a story and, you say you've understood it. But then now the questions come. I can ask you a lot of questions around that story. I can ask you questions from the lines. I can ask you questions from between the lines, more subtle. I can ask you questions from beyond the lines that have been written down about any topic. And the moment I start to do that, you have to go back to reading and finding out, there's more to this than I thought. It's the same thing with mathematics. You can do mathematics if you first understand what you're reading and what you're studying. Now, you can't read math and understand it. but you can unravel mathematical concepts through visualization. And that visualization helps you understand math. But that's not enough. Once you've understood it, you now extract from it principles of thought, of thinking, of analyzing, of organizing numerical information, how to convert them into tools that can help you solve problems. That's the path you need to go. And for that, you really need to know your concepts well. And that needs a certain kind of courseware. You have to develop courseware that makes mathematical very easy to understand, very simple to understand, very easy to explain, if possible, as a teacher. But because it does that, the demands on problem solving goes up, because the more you understand, the better you understand, the faster you understand, the better you should be at using that understanding and your knowledge for problem solving.